Wait, look at that. That is a literal doorway carved into Mars. On March 9th, 2025, the Curiosity rover scanned this exact coordinate in Gale Crater. According to planetary geology, everything you see here should be the result of billions of years of wind, thermal expansion, and slow, predictable erosion. Standard erosion models explain the dust, the dunes, and the craters, but they cannot explain what we just found sitting in the open Martian air. There is a massive gap between what our eyes are seeing and what science says is possible. Prepare yourself. We're going beyond the official narrative. Let's start this Mars in-depth investigation. Let's first have a look at what seems to be perfectly natural classic erosion. You see these stones aligned, showing the same directional patterns we've seen 1,000 times. It's easy to attribute this to millions of years of wind blast. It's comfortable. It makes sense, but in forensic geology, comfort is the enemy of truth. Everything lies in the details. You have to ask yourself, how can certain features exist under these specific atmospheric conditions? I found something here that defies the script. While the wind was supposedly carving the surrounding rock into smooth dust, it left this untouched. It didn't just ignore it, it seems to have worked around it. Standard models require uniform force, but what we're looking at is selective. It's precise, and quite frankly, it's compelling because it shouldn't be there. But this is only the start. This specific sector of Mars, and this frame from Curiosity in particular, is a nesting doll of mysteries. As we peel back the layers, the anomaly level doesn't just increase, it doubles. The background shows what appears to be standard sandstone, the official story of a dry, dead world. It's the perfect camouflage. But as we pull our focus back to the foreground, the landscape stops behaving. Standing out against the grain of the entire region, this isn't a trick of light, and it isn't a trick of the mind. While the background is being smoothed away by the eons, this structure is holding its ground with sharp, defiant geometry. Why would the same wind that pulverized the sandstone behind it fail to touch the object in front? If the environment is the artist, why is it using two completely different brushes on the same canvas? What kind of object do you think this could be? Now we move into the territory of the truly bizarre. What the official logs call stones, I call a challenge to physics. We are told to believe that wind erosion, specifically sand blasting, is the primary architect of the Martian surface. But look at this. How does a chaotic sandstorm produce a non-chaotic result? If you were to replicate these conditions in a lab, you could blast a rock for 1,000 years and never achieve this specific alignment. There is a massive disconnect between the process we're told is happening and the result sitting right there on the ground. So, if it isn't wind, and it isn't sand, what is it? The deeper we go into this Gale Crater sequence, the more the natural explanation begins to crumble. Look closely. We aren't just looking at rocks anymore. We are looking at a direct violation of geological probability. Here, two distinct objects are sitting within meters of each other, each presenting a different structural impossibility. The first one. Look at the right angles. Look at the circular radius. In nature, a right angle is a rarity. A right angle paired with a precise circular shape is a signature. Wind doesn't turn corners at 90 degrees and then decide to carve a perfect arc. Then we have the second object. It appears to be self-folding, almost like a layered fabric frozen in stone, complete with what looks like a structural knob or a protrusion. It defies the grainy, sedimentary logic of the sandstone behind it. Is it a component? Is it a fossilized anomaly? It's hard to say, but it is clearly, undeniably, bizarre. Standard erosion tells us that these should be shapeless lumps by now. Instead, we see deliberate geometry and complex mechanical-like forms. There is a massive gap between random erosion and right-angle precision. We're looking at a landscape that refuses to be explained by the manual. And as we move to the final piece of this puzzle, the anomaly level is about to go off the charts. Ask yourself a simple question. If you were hiking on Earth and found a perfectly rectangular opening carved into a cliffside, a shape that looks exactly like a doorway, would you call it wind erosion? Of course not. You'd call it an entrance. But because this is Mars, we are told to ignore our eyes. Here are two cases from Gale Crater that are among the most exciting I have ever analyzed. Look at the first one. The symmetry is staggering. We aren't just seeing a hole in the rock. We are seeing right-angled frames and an interior depth that suggests an opening rather than a crack. Is this a natural stone weathered by billions of years of wind? Or are we looking at the structural remains of something more intentional? Drop a natural or anomaly in the comments. With your reasoning, I'll be pinning the most detailed geological breakdown. Another rectangular silhouette standing out against the chaotic debris of the crater. It's sitting right there in the open, defying the randomness of the surrounding rubble. These aren't just compelling. They are a structural crisis for the standard model. I'm going to pause the data feed for 5 seconds. Look closely. Can you spot the structural inconsistency before I highlight it? Most people miss it on the first pass. Nature loves fractals and jagged edges, but it hates a perfect rectangle. There is a massive gap between a rock fracturing naturally and a structure that mimics the exact proportions of a portal. What we see are the hallmarks of design, standing in a place where design supposedly doesn't exist. If these are just stones, then they are the most statistically impossible stones in the solar system. Let's look closer at the measurements, because the math behind these doors tells a story the official narrative isn't ready to handle. Imagine a high-pressure jet of sand-laden air hitting a rock face at a fixed angle. If the rock has a specific grain or a pre-existing soft spot, the wind wouldn't just erode it, it would machine it. This acts like a natural sand cutter. It could explain right angles if the rock's crystalline structure already favored 90-degree cleavage planes. When a rock expands and contracts so violently every single day, it develops fatigue. If that rock has a specific mineral composition, like a cube-shaped salt or a rectangular crystal lattice, the thermal stress won't make it crumble into dust. Instead, it will snap along its molecular lines. This is how you get a doorway. It's not carved. It's a plug of rock that simply fell out because the daily freeze-thaw cycle acted like a precision chisel on the weakest rectangular joint. To get a perfect shape, you need the perfect rock density, the perfect wind angle, and the perfect thermal stress to align for 1,000,000 years. If the conditions are off by even 1%, the rock just becomes a shapeless lump, like the millions of others around it. The fact that it is the only one in the panorama suggests that it is a statistical outlier, 1 in a billion fluke of nature, or it confirms that it isn't a natural process at all. We understand erosion. We've spent decades mapping how Martian wind, sandblast, and thermal cycles grind mountains into dust. The model is solid. The math is proven. But that's exactly the problem. When the model is this good, we shouldn't have leftovers. We shouldn't find objects that treat these global forces as if they don't exist. So, if the erosion model isn't broken, but the object still exists, what are the alternatives? We have to look toward the uncomfortable. Could we be looking at exotic mineralogy? Materials so hard and so specific in their crystalline structure that they machine themselves into these shapes? Or are we forced to consider spazarchy? Or the idea that we are looking at the final, stubborn silhouettes of a structural history that was never supposed to be there? But this investigation has opened a much deeper question. If these shapes are unique to this specific coordinate Gale Crater, what is hiding just beyond the rover's camera range? Are these doors isolated accidents? Or are they the only visible parts of a much larger, buried complex? In our next mission, we'll be targeting a new set of coordinates, featuring structures that flatly defy standard erosion models. We are moving beyond speculation and into the data. Remember, once you recognize the pattern, you can no longer unsee the truth. I'll see you in the next archive.